So about a year ago, I worked on this really unpolished multiplayer game using WebSockets, and it was really fun to work on. I actually have a video that kind of outlines this process of how I built this. But when I did a live stream and I shared the link to my subscribers, one thing that really highlighted is that this game has a major limitation, and that it's not built for scale. Basically, when everyone joined this game, it slowed it down, and eventually the game just stopped working because I was hosting it on a single virtual machine, and it couldn't handle all the traffic. Fast forward to this year, I decided to take my game to the next level. I have a nice polished UI that's built with Next.js. People can go ahead and create new rooms. I have a nice region dropdown that allows people to create servers in various regions across the globe. I used AI to generate a nicer Christmas tile sheet that you can see in the game right here. I used this tile editor to build out a nice tile map for the arena. And then on the top right, I added a scoreboard. I also have a match timer of 3 minutes. And then finally, I topped it all off with some client-side interpolation to make the movements feel smooth and the snowballs not jittery. But I'll say even after polishing this game up, I still had that major limitation. I needed a way to figure out how to scale this when multiple people from my streams try to join it at the same time. Luckily, I managed to find a service called Hathora, which is the sponsor of this video, which allowed me to quickly add support for hosting my game server and also allowing me to spin up my servers in various regions across the globe and giving my users the ability to create game lobbies. Now, a little bit of background about me. I have spent a lot of time with AWS and working with infrastructure as code tools such as Terraform and AWS SDK. And I'll say the last thing I wanted to do on my snowball game was try to figure out how to automatically scale up as people connect to my web server. So luckily, Hathora saved me a ton of time by allowing me to just focus on my game and my features and not have to worry about all the hosting and the scaling. Now, to be completely transparent, I didn't know about Hathora until they reached out to me to do this sponsor video. And as I kind of scrolled through their landing page and learned more about them, I was excited to see that they actually use Hathora for another RTS game that I've been kind of watching called Stormgate. So if you're a long-term subscriber to my channel, you know I like RTS games, you know I like StarCraft 2, and I've actually tried making some side projects for StarCraft 2 build orders. But one of the games I've been kind of eyeballing is Stormgate, and I was actually excited to know that Hathora helped Frost Giant stress test 1 million concurrent users as they're building out their Stormgate real-time strategy. Honestly, that was enough to convince me that Hathora means business, and I think it could probably handle scaling my little snowball application with ease. So what exactly is the plan in this video? Well, I plan to do a live stream and kind of share with you all of my subscribers play testing a room together with 16 slots, and also show you how fast all these rooms can kind of scale up behind the scenes using Hathora in my live streamers. And then more importantly, I'm going to walk you through my Next.js project and my backend code and kind of show you how you can integrate with the Hathora TypeScript SDK to create rooms and tear rooms down, and then also give you my opinions on Hathora. But before we actually get to the fun part of watching people battle each other, I do want to make sure you all understand how complex scaling a game server yourself can be. So what I want to do is I want to walk you through the progression of how you potentially scale out your own game server so that you can actually see for yourself why something like Hathora would be such a great choice for your own game servers. All right, so let's start simple. Let's say you have a simple game server where you can have users connect to it. When you're first starting off, you may say, well, you know what? I could just host this on a VM. I'm going to draw a little box here that represents your VM. Maybe using DigitalOcean, maybe using EC2. And you want to basically have your game server live on that VM. So what you're going to do is you're going to spin up that VM. You're going to spin up that game server. And you're going to go ahead and point users to that hard-coded IP. Maybe you have like a DNS in front of that. But this is like the basic approach, right? Now you can make your game server very robust. You could potentially add logic to support multiple game rooms. At some point, you're going to hit limitations. Hosting your game server is going to eat up memory and CPU usage on the machine, right? You can't just have infinite amount of game servers running on this machine. Okay? So if you know anything about servers, the first thing that you can do to potentially increase how many things you can handle is you're going to do vertical scaling. Okay? This is often the first thing that you'll do to support more users and more traffic. And what this means is that you start off your game server, maybe you have 1 gigabyte of memory on the machine, and maybe you have one CPU. Okay, maybe it's a shared CPU, maybe it's a dedicated CPU. But this is what your like entry-level VM will look like. And at some point, it's not going to be enough resources to handle all of the traffic trying to run. Now, what that often means is you go into a UI, and you bump up how many CPUs that you want, how much memory you want. Maybe you want to do 2 CPUs and 8 gigabytes of memory. So this will work pretty well. As you scale up the actual virtual machine that's running your game server, what really happens under the hood is that you're just allowing your game server to be able to provision more rooms inside of it. So now instead of your game server only being able to handle, let's say 5 to 8 rooms, maybe it can now handle double or triple that depending on how much you bumped up the VM to. But I will say there are some limitations to this vertical scaling approach. The first one is you have a server that's running 24/7. So you will be charged every month for this dedicated VM to just sit there, regardless of if you even have players playing inside your game server or not. That's something you got to keep in mind. Also, how do you know when you need to actually scale up this VM? You typically would have to add in some type of monitoring. There's tons of different monitoring tools out there, but it's just another overhead that you'll have to hook into the VM to know when your game server is reaching a threshold of using up too much memory on the box or using up too much of the CPUs on the box, and you'll have to kind of keep that in mind. A third issue is multi-region, right? How do you take this and distribute it across the globe so that multiple people can play in their country with good latency? So unless you can find a service that kind of does this for you across multiple regions, this is something you're either going to have to use like infrastructure as code or some type of other approach to basically create these servers and have them running at all times and monitoring them at all times in your various regions so people can play. Another issue is failover. Now that you have a single VM that's hosting all your game servers, if for whatever reason that VM were to crash, how do you have it so you have a backup running so all your users can then connect to a backup VM? This is something you have to keep in mind. And then lastly, at some point with vertical scaling, you're going to hit a threshold where no matter how much more CPU or RAM you add to the box, you just can't scale up anymore. Maybe there's an actual physical limit with the cloud provider you're using, or maybe there's a limit with how you're writing your game server. Maybe the programming language is single threaded and you have to do a lot more architecture to basically spin up various threads when these rooms start. So these are all the things you have to kind of worry about with vertical scaling and concerns that come to my mind, which is why typically in web development, we try to do something called horizontal scaling. Okay, so instead of scaling the memory and the CPU of the box, we'll keep the box at like a normal smaller size that can handle your actual server. Maybe your game server can only handle maybe 5 rooms, but the idea is now when you're horizontally scaling, what you do is you take this entire approach and you scale it to multiple machines, so that users can automatically connect to the game server that they're interested in, right? So one server might be hosting one room that all your users will connect to, and this other server might be hosting a different room. So this is the next logical step, because if you're going to hit a limitation at some point with vertical scaling, you might as well just start with horizontal scaling if you have the ability to. Now, a lot of service providers, they will say that they give you horizontal scaling, like you can change your scaling max number for how many nodes you want. But behind the scenes, if they're using a load balancer, then your WebSocket server may randomly connect people to various servers, and you may not have that fine-grained control over that. So that is one thing you need to keep out for if you plan to use an existing hosting service that does auto-scaling groups for you. But this is how a lot of web applications actually work. If the traffic keeps increasing, you have to write some type of scripts, or you have to basically use a service that's going to continuously add in more servers. It's going to create a game server. Somewhere it's going to register that server IP into a centralized registry so that your users know what server they need to connect to when a game server spins up. And there's also a lot of additional complexity around if no one's playing your game, you don't want these 4 VMs just sitting around. So you want them to kind of like tear down over time to save you operational costs, right? Okay, so now let's say your game gets super popular and it's now a globally played game like StarCraft 2, maybe Dota, League of Legends, and you need servers that operate across the entire globe. So now what you end up needing to do is you have to kind of do this approach, but you have to do it in various regions across the globe. So over here you might have like a US East setup, and on the right you might have like a European Union setup, and then you might have like a region in Asia, you might have somewhere in the West Coast. But the idea is you're going to end up having to do the same horizontal scaling and figure out where to connect users based on the regions that they want to spin up, which isn't really straightforward, right? A lot of cloud providers do give you multi-region support. Like I use AWS at work, where you can go and you can create multiple servers on various regions. But again, figuring out all the infrastructure behind this and how to automate all this, it can just become a lot more complex. Now, hopefully it's apparent why you want multiple regions. Obviously, if you have someone who lives in Asia and they're trying to connect to a server that's on the East Coast of the United States, their latency might be like 300 plus milliseconds, right? So when they try to move their character, there's going to be a huge lag or delay. And if they were to, for example, a first-person shooter, they were to shoot their gun, their shot is going to be super delayed compared to someone else who might actually live on the East Coast, like let's say they live in Virginia or something, their milliseconds might be 50. So without having multi-region support, people from other parts of the globe are just not going to be able to play the game, right? You end up having to have multiple regions if you're planning to make any type of multiplayer game that you want people from around the globe to kind of play with each other. All right, so all this brings us to our last point of Kubernetes. Now, I personally have not had a chance to really use Kubernetes in a production environment. I really hope one day I do get a chance to get hired to learn about Kubernetes, but overall, Kubernetes is a way to basically automate a lot of this orchestration for you, where you can create a Kubernetes cluster, where you can say, spin me up a server or a pod with X amount of memory, X amount of CPUs, and it'll figure out how to put that server on a region that you specified automatically for you. Now, there's also a bunch of additional things you can do with Kubernetes, like hooking into WebSocket events to know when WebSockets that are connecting to your servers are idle, so that you can write code to automatically tear down these game servers when no one's actually connecting to them. Now, I've spent about a day trying to understand Kubernetes, and I will say it's not very easy to get into, right? There's a lot of terms that go into Kubernetes. There's like services, there's pods, control planes, networking, Docker containers. But this is ultimately, I think, where you want to try getting to if you want the ability to quickly spin up and tear down VMs and have a lot of control over how all this stuff works. So that leads me to Hathora, where Hathora uses Kubernetes to kind of do all of this hard, complex logic that I talked about for you. So for example, if you have a player who wants to spin up a game room and play with his buddies who live in India, he can do that. And behind the scenes, Hathora basically creates a pod using Kubernetes. Going to spin up that instance. We're going to get a URL that we can have the users connect to. And when they're done playing their game, that pod is going to automatically tear down. So the main benefit of that is I don't have to pay for a dedicated server. I just have to pay for my usage. And that is one thing I really like about Hathora, is that you pay for your usage. You pay for your Hathora compute units, and then also you pay for your bandwidth, right? So if you have a really optimized game that doesn't really use too much bandwidth, such as my snowball game, then I won't have to pay too much. For example, I signed up for a Hathora account. I've done multiple live streams and I've tried to have people join and play my snowball game, and I haven't even reached $1 of credit usage. So it's a great way to have all of this functionality with multi-region support and scalability without having to pay too much money. Now, I do plan to show you how I integrated my snowball game with Hathora. It's really straightforward. They have a nice JavaScript and TypeScript SDK that allows you to quickly spin up rooms and tear them down and get information about various rooms. But they also have support for Unity, Unreal, and Godot. Now, another cool thing about Hathora is that they have support for various matchmaking services. So one common one from Microsoft is PlayFab. And Hathora can hook into PlayFab to basically spin up rooms for your players when they want to kind of set up a match. For example, if you ever played like Call of Duty and you ever need to find a match, you can use one of these existing matchmaking services and hook it into Hathora as well. They have information in the docs about this if you're interested in reading on it. So how exactly does the lobby creation process work? This is something you can apply to any type of game server. It doesn't have to be Hathora specific, although Hathora does make this a lot easier. Let's say you have a user who lives in Australia and they want to create a new game server. So what they can do is they can use the Hathora SDK and they can say create lobby, and they can go ahead and provide it a region. So I'll just say like Sydney. And that's going to contact the Hathora services, and that's going to tell it to spin up a game server in a region. So I'll go ahead and draw a game server. And what you get back from the SDK call is a lobby model, which happens to have a room ID on it. Okay. So this room ID is what's going to allow you to figure out how to connect your users directly to this game server that dynamically got spun up. So once you get that WebSocket connection URL, we're going to go ahead and say step 4, using room ID, look up WebSocket connection URL, connect user to the game server. Now in our case, what I did is step 5, the game server can actually run multiple rooms. So you can have multiple people creating rooms that all happen to live on that same node process. And that allows us to save money because you can actually utilize more of the machine, CPU, and memory, and just run multiple rooms on that node process. So if that game server room ID has not been seen before, we're going to go ahead and spin up a room inside the node code. All right, so this is our code. Step 5 is our code, where basically I listen for a new ID. If I haven't seen it before, I'm going to go ahead and spin up a logical game room in my code, which is going to start listening to certain user connections and move those players around and make sure that all that stuff is kind of isolated per room. Like I mentioned, the server itself can have multiple rooms, and you can actually configure this in Hathora, and you can say, hey, I only want 5 rooms on a node process. So if you have a bunch of users that are connecting from Australia and they try to keep on joining the same region, what ends up happening is after you get to 5 rooms, Hathora is going to go ahead and just spin up another node process, right? So say after X amount of rooms, spin up another node process. And then that one is going to be able to accept up to 5 more rooms as well. So again, there's a lot of orchestration that's happening under the hood for us that makes it really nice. And I don't have to worry about any of this. Now the great thing about this is after all the WebSocket connections are done, let's say all the users close their tab or all the game rooms end, and no one else is trying to connect to Sydney, Hathora is going to go ahead and just watch for those connections. And if they're all idle after about 5 minutes, it's going to delete your game server, and you are not going to get charged any longer for that running instance, which is pretty nice. Also, you can use the SDK to delete rooms. So for example, after the timer has expired in my game or a user gets to 10 kills, I can go ahead and have my node process tell Hathora to just tear down this room, and that'll not allow anyone else to connect to it. And then also all the rooms that are being displayed in my game, those are coming from the Hathora services as well. So I don't have to worry about creating my own database to manage those rooms and allowing other people to find them. So that's kind of the overview of how Hathora works and the complex logic of dynamically provisioning and tearing down game servers. So I highly recommend checking out Hathora to do that for you because it's super easy using their services. So now I want to walk you through this code and how I set this up to easily get this running for all of my users. Now I will say all this code is going to be on this repo link, which I'll have in the description below. So be sure to check it out if you want to see how I built this. So how this works is I have a front-end client, which I'm using Next.js, and this is being deployed to Vercel. Okay. Now the backend is just a node process written in TypeScript, and that is containerized and deployed to Hathora. So I'm going to start with the backend and show you how that game server is set up, and then I'll kind of walk you through the front end as well. So in order to get the backend working in Hathora, they use Docker containers. So I had to build a Docker file, which basically just runs command to get my node process running. Nothing too crazy here. It just, does npm CI to install the node dependencies, and then it runs npm run start. Now what npm run start is going to do is it's going to actually run my game server. Now the game server just creates an Express server and a WebSocket server, so I can start having people connect to that WebSocket server. Now what I do in the front end is when you're trying to connect to a server, I also pass a room ID. And if this game server has not seen that room ID before, it's going to go ahead and create a brand new room and send that back to the user so they can start playing with other people. But the main thing is every time a room is created, you basically need to have an isolated set of game logic, all your players, your snowballs, your game state. It all needs to be kind of encapsulated inside the room so that you can actually have a lot of these dynamically spin up and spin down without affecting the other rooms that are currently playing. I'm not going to walk through all the lower level like game implementation detail logic, but basically every room has a tick that runs about 20 times a second. And I listen for player inputs, I move the players around, and then I broadcast the game state to all of the users who are connected to this specific room so they can see other players moving around and throwing snowballs and stuff. And then I have logic around when a snowball hits somebody, I basically increment their score, keep track of their losses, their deaths. So you can look through the code if you want to actually read through the implementation detail of the game server, but I want to talk more about how do I get this stuff all deployed out. So I use a GitHub action, which is actually going to automatically deploy all of this backend server logic to Hathora on a git commit. So when I push changes to main, this is actually going to run this GitHub action. If you're not familiar with GitHub actions, basically it's a way to automatically run some tasks when you push code to your repo. So in our case, we want to deploy all of this stuff to our Hathora service, where basically all I do is I do a Hathora cloud deploy. I pass it some configuration details such as how big the VMs need to be, how many rooms I want to live on a node process, some environment variables, etc. And that's about it, which is great because every time I do a git commit, it's going to go ahead and deploy those new servers to Hathora. And then when people create new rooms, they're going to get those new changes. So I don't have to do much work at all to get new changes deployed out. Now, one thing I want to point out is Hathora has a Cloud SDK TypeScript package, which I'm actually using for spinning up game rooms and tearing them down. So I'm just going to go ahead and open up one of my room models here, and I'm going to walk you through some of this. As you can tell up here, I'm importing that Cloud SDK TypeScript package. And when I do that, I have access to basically call the Hathora SDK. So from this SDK, the main namespace I'm using is the room v2 namespace. And that has some methods on it, which I use basically when people connect to the server, I need to keep track of how many players are in the room. So I'll increment or decrement based on that. I have another method which basically uses the v2 get room info. So I can grab all the room information to know what the max capacity of the room is when the WebSocket server is trying to spin up a new room. And then down here, I have a way to destroy the room when the game is over. Remember that timer, when the 3 minutes is up, I go ahead and tell the WebSocket server to destroy this room, and that'll remove it from the lobby list and also free up the CPU and memory of that room that's running on my server. In order to connect to the Hathora SDK, I'm just importing this Hathora cloud, creating a new instance of this class, and then just passing an app ID and then also a token that you'll find in your Hathora dashboard. So that's about it for the backend. I do want to talk about how I did the front end. So for the front end, I just set up a Next.js application, and I'm having this be deployed automatically using Vercel. So when I push to the repo, Vercel is going to see my changes, rebuild my Next app, and get that deployed out. Now, hopefully you already understand how Next works. That's basically what I do on this channel. I do a bunch of Next.js tutorials and talks. So now I want to kind of walk you through some of the front end features and how I create lobbies using Hathora. So if I go to this lobby page, you'll see here there's a create room section component, which has a form with some room names, some region information, some max players. And then once they actually try to submit this form, it's going to call a create lobby function, which uses the Hathora SDK to anonymously log in. This is for getting like a user token. You'll need this to be able to do some operations such as creating a lobby. Going down here, I call Hathora client lobby v3 create lobby, and I pass it some configuration for the room information. So you can make public rooms, you can make private rooms that only you and your friends can join. And then if you're running locally, you can just use local rooms. You can specify a region, and then this room config is an option that you can pass to provide whatever custom logic that you want. So in our case, I have a capacity. I only want a certain amount of people to be able to join a room. I want a max score set to 10, the room name, and then also keeping track of how many players joined that room. Okay, so calling this is going to do what I mentioned in the diagram, where it's going to spin up a new node process in a VM somewhere across the globe if one doesn't already exist. Otherwise, it may just utilize an existing node process and just kind of create a game room, depending on the region that you picked and how many people are currently playing your game. All right, so let's just go ahead and pick Washington. I'll go ahead and click Create Room. And as you can see, going back to the Hathora dashboard, it is creating a room here. You see the status starting over here. And now that game room is set up, and I've connected the front end to that game room. All right, so now I'm going to walk you through how did I get the game to actually connect to this WebSocket? Because remember, these servers are kind of spun up dynamically on various endpoints. So you'll have to use the Hathora services to figure out where that WebSocket connection is. And you'll notice in the URL here, we have a room ID, which I'm passing to this path, and I'm going to use that to figure this stuff out. So let's go back to the next code real quick, and notice that we have a game route, which is going to take in those params where I'm trying to get the room ID from the URL. And what I do is I start a new game client and I pass in that room ID. So if I look at this game client, I pass in room ID, and you'll see that it does a request to get the connection info from Hathora using that room ID. Okay, so down here, this will give you the host and the port that you need to connect to. And all I need to do is just basically set up a WebSocket server connection to that URL. Looking at this method again, this is just using the SDK I talked about, where it does a request to room v2, get connection info, and then I can kind of send that back and connect. Now, in terms of the client game server code, it's pretty straightforward. I basically just listen for some events from the servers, and I update the players and the snowballs data structures as those events come in. I did add a little bit of client-side interpolation to kind of smooth out movements. And I also listen to window events such as mouse movement and key up and key down. I send those to the server so the server can actually process on the user inputs when it runs its game server tick. So at this point, multiple players can kind of join a room, start playing around, throwing snowballs at each other. But I do want to point out, when the timer expires or a user gets to 10 kills, how does that logic kind of work? How do I automatically tear down the game room and have all the users go to a disconnect screen? So going back to the create room function inside of this room file, I have a game length which specifies 3 minutes. And basically when a new room is spun up, I set a timeout. And after 3 minutes, I'm going to go ahead and end the room if there's no more players in the room. But if there are players, I go ahead and call declare winner, which basically broadcasts a WebSocket event to all of the currently connected users of that game room. And that's going to tell them to redirect to a game over screen with whoever won. But more specifically, what I want to show is that there's an in-room function here, which basically contacts Hathora and calls a destroy room function. So if you look at over here, we have Hathora SDK room v2 destroy room. That's just telling Hathora that, hey, you can actually remove this whole room from your list of rooms so people can't connect to it anymore. And then also it'll tear down the VM if the node process no longer has any rooms at all or any WebSocket connections running on it. So now let's go ahead and do a live stream. I have a bunch of subscribers on my YouTube channel who are connecting to my server. For everyone who's watching the stream, could you guys just go ahead and just create a game room, like create as many game rooms as you can. Just go over here, select the region that's closest to you, and just go ahead and create those rooms. I want to kind of demo the way Hathora works behind the scenes that just allows people to quickly create game rooms and have those be torn down after they're no longer used. So as you can tell, people are creating rooms and those are dynamically showing up for us. And I can actually go through here and play with anyone here. So here's a low latency. Let's go to Soon He. Let's see if I can go play with them. I'm trying to hide behind a tree. Still got him though. All right, so to kind of demo Hathora, notice that as people are creating their rooms, those rooms are going to be put onto existing node processes if they're not already filled. I think I have my limit set to 5. So if more people try to create in Washington, D.C., it'll just go ahead and create another node process and put the rooms on there. I can also dive into these rooms and see what the connection counts are, how much bandwidth that room is using, how much CPU utilization the server is using. I can see the active room. And also down at the bottom, I get some nice logs where I can actually see people connecting and disconnecting from the room. And if the room were to throw an error, I can see those happen down here as well. All right, so the second thing I want to stress test is I'm going to make a room with max players of 16, and I want to see if this is going to be super laggy. So everyone who's in the chat, if you want to leave your current room and find the room called WDC Super Room, I'm going to go ahead and create this in Washington, D.C. And go ahead and join. I want to see if this room will fill up. I'm going to hide my phone, my face real quick. I'm just going to keep walking around throwing snowballs to make sure it's still good. But overall, I mean, it seems like it's pretty responsive. Oh, crap. This game's so hard to play. Your mom is leading the leaderboards right now with 7 kills. Oh, no, I think your mom's going to win. So the last thing I want to point out is that if you want to increase the plan size of your Hathora application, right now I'm using a teeny size that uses a shared core for the node process and also 1 GB memory. But if you want to support more rooms on a server, you can quickly bump that up, which will kind of reduce how many node processes will be spun up. You can also change the number of rooms. So here I have it set to 5, but if for whatever reason I wanted to reduce how many rooms are on a process, I could reduce this to 1. And then also your environment variables down here that you can kind of update. All right, well, that pretty much wraps up my overview of how I built out that snowball throwing game. Hope you guys enjoyed it. Hope you guys learned something new. Like always, the code is in this URL. I'll go ahead and put it in the description below if you want to kind of take a peek through it, because I do plan to actually continue working on this. So if you want to get the code as it was when I made this video, make sure you click on the right commit so you get the right hash and you can see that code. Otherwise, you might see a lot of additional progress added onto the snowball game as we add features to it. My final remarks is I want to say thank you to Hathora for reaching out for this sponsor video. I learned a lot using their service, and I'm actually really excited to maybe even use this to build out more games in the future. The user experience is great, the developer experience is great, and it was really easy for me to just start integrating with them to have my game scale across the globe for people to kind of play with each other. So definitely go check out Hathora. They have a lot of good docs that kind of walk you through how you can do this with JavaScript. They have some example projects that you can use. For example, I kind of looked through this Bullet Mania to kind of, take some pieces from it to incorporate into my own. But they also have support for like Unity and Unreal and Godot if you're interested in kind of using those libraries. All right, that's about it. Be sure to give me a thumbs up if you like this video. And like always, I got a Discord channel you guys are welcome to join. I'm going to create a dedicated sub channel in my Discord for this game itself. If you guys want to ask me questions about it or maybe contribute to it in the future, I may have a community start adding features into this game to make it more polished. Have a good day and happy coding.